Good morning. Today we are continuing on, or actually it might be good afternoon. It is the day 2. Okay, so hello. Today we are continuing on with those functions. We are doing Co49. I can graph a function using a function table. So we worked with those tables and we worked with finding rules. We worked with tables. We're putting a lot of things together in today's objective. So it's lots of stuff that seems confusing and overwhelming, but it's just putting together a lot of things that we actually already know. We know how to graph. We know how to read a function table. We've talked about finding those rules. Now we're putting the rules to a function table. So remember that in a function table, each pair of x and y values represent an ordered pair that we can graph on our coordinate plane. You can graph a function using a function table by plotting each ordered pair on a coordinate plane and connecting them with a line. Remembering that lines have the arrows on the end because they go on forever. So if we're drawing a line, make sure you put the arrows on. It is not a segment. Remember, that's different. So for each function table below, we're going to write out each ordered pair contained in the table. That's pretty basic and easy. Then we're going to write a rule for the table. We're going to have to look to see how is the y's, how are they increasing or decreasing dependent on the x that is the input. So how is our input increasing or decreasing? Is there adding, is there subtracting, is there multiplying or dividing, or is it a two-step with both? So we're going to look at that. Then we're going to graph the function. We're going to take those ordered pairs and we're going to graph them. Again, that's an easy step. Then our last step is we're going to list an ordered pair that's not included in the table, but that is on the line. So we're going to use our rule that we came up with for number 2. We're going to use that rule to find another ordered pair. So I'm going to show you how to do that. So the hardest step is going to be figuring out the rule for the table. So our first step is we're going to write those ordered pairs. X, Y. We know with our ordered pairs, it always goes X, Y. So -2, 0, 0, 2, 2, 4, and 3, 5. So you must show your ordered pairs. That's part of the steps in the directions. Then it says write a rule for the table. So remember that output is always going to go like that. Y equals, remember when we talked about those rules, those outputs, that's how we set up the rule. So y equals, what are we doing to the x to get our numbers on the side? So I like to look to see how are they increasing. So if I look here, I can see, ooh, there's not a -1 listed. There's not a 1 listed there. So it's not an exact pattern that I'm going to be following, saying, oh, from 0 to 2 to 4 to 5. But I can look and see, all right, so I have an x. If I put in my x of 3, how do I get to my y? Well, there's 2 more. Well, let's look at a different x. If I put in an x of 2, oh, there's 2 more to get to my y. I put in an x of 0, there's 2 more to get to that y of 2. So I'm looking at that saying x plus 2. Every time I put in that x, if I put in a -2, if I put -2 plus 2, I get that 0 for my y. So I'm increasing, going from x to y, I'm increasing it by 2 every time. If it is consistent like that, we know we are adding. It's always going up by 2, so I'm adding 2. Sometimes our numbers will be increasing, but it's not going to be by the same number every time. That's when we look at multiplication. Or we look at maybe we're multiplying and adding. So we have to look to see, is it a 1-step or a 2-step? For this rule, it was a 1-step. Now I'm going to graph my function, so I'm going to look at those ordered pairs. -2, 0, 0, 2, 2, 4, and 3, 5. I'm going to draw my line, putting the arrows on the end, and now I need to say what an ordered pair is that's not already listed but will be on the line. I am not going to eyeball it and say, well, it looks like this point falls on the line, because my line isn't exact. Okay, I am not perfect when I draw my line, and neither are you. So we have to do the math to prove it. So I'm going to take an X that is not listed. So I see 1 is not listed. I'm going to put a 1 in for my X. 1 plus 2 gives me a 3 for my Y. That is my ordered pair that is on the line but is not listed in that function table. So you're going to put in your X and then do the math for your rule, and you get the Y for your answer. So your ordered pair would be that X and that Y. So I come over here, I'm going to list, first thing, list my ordered pairs. So I have -3, -2, -1, 0, 0, 1, and 2, 3. So now I need to look, how are my X's going to my Y's? Am I increasing or am I decreasing? If it's increasing, you're going to see some multiplication or addition. If you are decreasing, that would be subtraction or division. I look here and I say, well, to go from 2 to 3, it goes up by 1. From 0 to 1, it goes up by 1. -1 to 0, it goes up by 1. -3 to -2, it goes up by 1. So again, remembering we put the Y on the outside, Y equals, our input equals, and I could see I'm going up by 1 every time, so X plus 1. Now I'm going to graph it. I have -3, -2, -1, 0, 0, 1, 2, 3. I connect them all, trying to draw as straight as a line as I can. I put my arrows on it to show that it is a line, not a segment. Then I have to do the final step. List an ordered pair that's included on the table, or that is not included on the table, but that is on the line. So I'm going to take an X that is not listed. I see a 2 as my biggest X. How about we try a 3 for X? So I'm going to have 3 plus 1. So that gives me my X is 3. 3 plus 1 equals 4. So my Y would be a 4. So 3, 4 would be on the line, but it's not listed in the table already. So let's look at the bottom of this page. We have -3, -6, 0, -3, 2, -1, 6, 3. So you're going to write out your ordered pairs. There are 4 in the function table, so you need to have all 4 listed. Then we go and look and say, okay, what's our rule? How am I going from the X to the Y? To go from 6 to 3, well, that could be -3, or it could be divided by 2. I'm not sure. So I need to have more than one ordered pair listed. I need to have several so I can see what that pattern is. Is it divide by 2 or is it -3? So if I look at to go from 2 to -1, ooh, that would be subtracting 3. So I have a -3 here, I have a -3 here. To go from 0 to -3, that's a -3. To go from -3 to -6, that's a -3. So I know that my Y equals X minus 3 for my ordered pair. So I need to write my ordered pair. I need to find what that rule is and making sure that rule applies to every single ordered pair that's on there. Sometimes the rule might work for 2 of them, but it doesn't work for the other ones. That's why you have to do it for every one. Make sure that rule works for all of them. Then you're going to graph it. So you're going to put your points on that graph, draw your line with arrows. Then you're going to say, what is an x that is not already listed on my function table? I don't see a 1 on there, so I'm going to put a 1 in for the x. 1 minus 3 equals negative 2. So my ordered pair would be a 1 for the x and then negative 2 for my y. I want you to try doing that last one by yourself. So you're going to finish off the bottom of this page by yourself. Because I want to go to the next page. It does get a little more complicated. It's not always just adding or subtracting. Those are easy peasy. So let's look at our second page where it gets a little more complicated. So you're going to finish off the first page on your own. Let's turn to your second page right now. So we're going to have the same 4 steps. Write your ordered pairs. So negative 2, negative 4. Don't forget those negatives. They matter. It puts us at a different point on our coordinate plane. Negative 2, negative 4, 0, 0, 2, 4, and 3, 6. So I'm going to look at my function table. How am I going from the x to the y? So I see 3 to 6, well, that's plus 3. 2 to 4, that's plus 2. 0 to 0, that's not adding or subtracting or anything. Negative 2 to negative 4, that's subtracting 2. Oh, hold on. Can't be the adding or the subtracting because I'm not getting the same thing every time. So then I need to look and say, am I multiplying or dividing? Because it's not clear with the adding and subtracting didn't work, so now I have to look at multiplying or dividing. So to go from 3 to 6, I can multiply that by 2. To go from 2 to 4, I multiply that by 2. To go from 0 to 0, can I multiply that by 2? 0 times 2 is 0. That would work. Negative 2 times 2. A negative times a positive gives me a negative 4. So that works. So that tells me that my input of y equals 2x. Because I know 2 next to the x means multiply. If you wrote it and said y equals x times 2, they mean the same thing. Remember, we can reverse when we multiply. 2 times x, x times 2, I would accept either way. But we do need to remember that the proper mathy way to write it would be 2x. We don't have to put that multiplication symbol in between the number and the variable. So this is the proper mathy way to write it. This way underneath is acceptable. If you were to write 2 with the multiplication symbol, x. So if you were to write 2 times x, x times 2, those would be acceptable answers. They mean the same thing. We need to recognize that the mathy way means both of those ways also. Then we're going to graph it. So negative 2, negative 4, 0, 0, 2, 4, 3, 6. Now, when I first started, I forgot that there was a negative 4. I started to put my point up here. My way of checking and saying, ooh, did I graph correctly or did I make that really simple math mistake, is my points should all be on the same line. That point is not on the same line. I messed up somehow. So that is your checkpoint. Did you accidentally put a positive instead of a negative? Okay, if you have a point that doesn't fall on that line, obviously, like that one doesn't fall on the line, you know you made a mistake, go back and double check how you graphed it. The last step, I'm going to take my rule, y equals 2x, and I'm going to put in an x that is not already listed on my function table. Again, I don't see a 1 on my function table, so I'm going to put a 1 in for my x, so y equals 2 times 1. That's the same as writing y equals 2 times 1 when you have a parentheses around it. We know, just like when it's right next to a variable, when it's right next to the parentheses, it means to multiply. So these are just those invisible math that we need to recognize. So 2 times 1 is 2. So if my x is 1, my y is going to be 2. So I'm going to go back and check, does that look like it fall on the line? If my x is 1, my y would be 2. And it's a little bit off with how I drew it, but that's because I'm using the smartboard and it's not drawing exactly well. If I lined it up better, would that have fallen on my line? Yes, it would have. Because you can see my line, when I was drawing it, fell below, see, I'm not calibrated right. It fell below my dots. But if I look at where each of those points are, it looks like it would fall on that line. I need to go by the math instead of by what it looks like. It looks like it wasn't on the line, it's too high, but math tells me yes, it actually is on the line. If it was way off and it was like over here, that's obviously not right. I did my math wrong somewhere. But if it looks really close, go with the math, okay? Let's do the one underneath it. So let's look at the one underneath. You're gonna, again, write your ordered pairs. You're going to graph those ordered pairs. I'm not gonna do that with you. I want you to do that on your own. But I do want you to look at how our x's relate to our y's. To go from the 6 to the 3, it could be -3, but to go from 2 to 1, that's only a -1. So I can't do -3, -1, they are two different rules. I could say 6 divided by 3, or 6 divided by 2, so I could divide by 2, that would be 3. 2 divided by 2 would be a 1. Shh, let me finish this super quick, give me 1 minute. 0 divided by 2 would be a 0. -4 divided by a -2 would be, -4 divided by 2 would be that -2. So that works. So my y would equal my x divided by 2. I could do y equals x divided by 2. Some might even say it's y times a half. Or y equals x times a half. So all of those actually mean all the same things. So however you write that rule, as long as it means the same thing, it counts. Plug in an x that is not on the function table and you will get your ordered pair that's not already listed. If you have questions, make sure you ask Mrs. Larson or a friend, and I will be helping us with this on Monday for any other questions. I hope you are well, and I hope to see you soon. Have a wonderful